In this lesson, we are going to learn about post-processing. You might have about post-processing. Post-processing is about adding effects on the final the final image, and we usually see it in filmmaking. You know, like Michael Bay movies, or even every movies. You have like some color management, you have effects, you have I don't know, and it can be anything. I'm going to give you some examples after. It can be subtle, just to improve like the color, or it can be like huge effect when you cannot even see what you had before, like in Predator or movies like that, when you see with the eyes of the alien. Well, it can be very different. So you can use post processors for depth of field, for bloom. We are going to do some of them to create a God ray effect. If you don't know God ray, I will show you later. To create motion blur, you know, when things move too fast, they are kind of blurry. To create glitch effect, like if the screen is being hacked. To create outlines around, I don't know, a character you just selected for RTS game or something like that. To do some color variations, just in order to be able to find the perfect tint, the perfect color. To do aliasing. Yes, we've been doing aliasing, but you can do aliasing using post-process, and we will do that, but also to make reflections, refractions, and many other things. And we are going to try a few of them and to discover a lot. So yeah, about the setup, yet again, we use the realistic render lesson result, but this time it's not the same, you know, old helmet like aviator helmet. This time it's kind of futuristic helmet. This is called the Damage Helmet by Leonardo Carrion. Thank you for letting me use this this helmet. It's just beautiful. I just wanted to use it because it's just too good. So I put the link of this Damage Helmet and the Leonardo Carrion website on the links panel as always. So how does post-processing work? I'm going to explain to you post-processing. It's going to be complex. It's going to be quite hard, but do not worry. It's going to be fine. You will see why later. So instead of rendering in the canvas, what we are currently doing, we ask the renderer to do a render where we can see the result in the canvas. We will do a render in a render target. So let's do some drawings. I'm not sure my drawings will be really useful, but anyway, I will do it just in case it might help some of you. So if we have, let's say, this is our final render, this is our screen. Like I will draw like a computer, something like that, look something like that. Here is the webcam, here is the screen, like that, like that, like that. We put just a stand so we really understand that that's a computer. Cute stand. And we do, I don't know, like there is a scene, there is a guy saying, hey, hooray, like that. There is a camera taking a picture, like that. This is a camera. Like that. The camera will take that picture. There is maybe a, I don't know, like a light, like that. Doing something like that. So this is our scene. This is our render. Currently what we are doing is that we take everything and we render it inside of there. As you can see, I let a lot of room here because we are going to put a lot of things here. And we get this little guy here saying, hooray. It's not as good as my previous drawing of the head, Lee Perry's Smith head. Anyway, this is what we are currently doing. When we want to do post-processing, instead of putting this render inside, so I can remove that, inside of the canvas, at the end it's the canvas, we will put it inside what we call a render target. I will use, I don't know, maybe that, like that. Not too big because we need a room. And we will draw the same thing inside of that. This is the common way of, I'm describing the common way of using post-processing. It can diverge, and this is why I'm explaining all of this. We put that in a texture, a render target. A render target, it's like a texture. It's like a rendering texture. You just put it inside. You cannot see it currently, but it's just like in the memory of JavaScript, not just JavaScript, you will see why, but it's just a texture. So you put it in a texture. What you do then is that you create a new camera, a new scene, like a brand new scene with a camera like that, with the usual stuff like that, like that. This is a new camera. It's not as good as the first one anyway. And you will create a plane in this camera. Like, I don't know, maybe a plane like that. It's smaller anyway, it's not a problem. So yeah, maybe like that. All right. And the camera is facing that plane like perfectly, like that. It's just facing this plane. And this plane, so it's just a plane, like a classic 3GS plane with two triangles. We will take this texture and put it on that plane. This way, you will see this little guy here, like that. But this is not an ordinary material. It's not like a mesh basic material. This will be a shader material. And instead of just drawing that texture on the plane, we are going to add effect in the fragment shader. All right. We will add, I don't know, like, let's think of simple effect. I will add a simple gradient at the bottom. It's not a crazy effect. It's not God ray. It's not, stuff like that. Anyway, I will just put one effect. And then with this camera, we will do a render and then put it on the screen right here. And instead of having just the guy from the first render, we will have the guy from the first render plus the effect we added here. And that's all. This is post-processing. But let's go a little further. You can add multiple passes. Let me check if I do things in the right order. Yeah, by the way, so this is what we call a render target. So this is render target. Oops, target like that. Like that and like that. So this is a render target. Cool. We also call it buffer or buffer texture or render buffer or buffer render. There are many words for that. So it depends what library you are using. We're using 3GS, so it will be a render target, and we will use that name render target because it's a class. So we are rendering the scene into the render target. Let's move forward. We use that texture on a plane facing the camera and covering the whole view. All right. It's not the same scene, but in this scene, we don't have our guy, our light, stuff like that. We just have a plane with a camera facing the plane, and we will do a render. But this is not an ordinary plane because there is a shader material on it. And positioning the plane, we don't care. We just put the plane in front of it. But when we colorize each fragment, we will use a custom shader that will add effects on it. Yeah, that's it. Those effects are called passes. I don't know if I already said the word, but yeah, this is a pass, and I'm going to use this word now. All right. Well, instead of effect, I will say a pass. So right now, what we did is add a gradient path. You can do whatever you want. We did a gradient path. So this is great. This is how we do things. Let me just reduce this part here. All right, just to have a little more room. The problem is that it's not a problem. It's a good thing. We can do multiple passes. The first passes we did is to add some kind of gradient at the bottom, which is great. What if we want to add more passes? And we can add more passes. We are going to have a problem. The problem is that when you want to add multiple passes, we have, instead of putting it there, so we'll do the same thing. We want one pass that add, I don't know, a gradient at the bottom, and another one that will add, I don't know, like that will add like waves, like we do wave with the texture. Anyway, we will do real things after. How can we do that? So we do the first render. It looks like this. So we use, I don't know, white is good. So we put it in the render target. Then this render target, we put it there. But we don't want to add it to the screen. We want to create a new pass. To create a new pass, this is the part where things get complicated. We need another render target. All right, we need a one like this. And the idea is that we did the first pass, but we are not going to put it on the screen. We are going to put it on the other render target. And we will draw the same thing. So this guy there, so right now we don't have anything here because we didn't render here. We have our little guy here. We have our effect because we already added the gradient effect. And we are going to put that texture. So the next step, we will put that texture back here. All right. And then again, we will add effects on it. And I'm going to do, I don't know, some kind of a wave with the UV, so stuff like that. Why do we need two render targets? Well, it's because you cannot write in a render target while reading the other render target. This is why we need two render targets. I know it's the part that things get complicated, but it's just the idea. You cannot write inside a render target while reading this render target. So you're reading the first texture, and you cannot write in another texture while reading the first texture, which is why we need two render targets. So this one will be RT2. And if we want to add more post-processing, so we still didn't add anything on it, so I will add this effect. I will ping pong, I will switch them in order to write on one and read on the other. And another pass, I will ping pong, so I will switch them, write on one and read on the other, and write on one and read on the other. And as long as I have passes to do, I will just ping pong with the render target. I write on one and I read on one. Ping pong, I write on one and I read on one. Ping pong, I write on one and I read on one, which is why we need two render targets. So the idea is that we add this effect. So we add it back here and we write it here. So it's going to be something like that. And then we ping pong them. And then now we are going to add, I don't know, like stars, shapes everywhere above the image. And here we are going to draw it with all the effects like that. And with the little stars right here. Like that. And actually, this is wrong because the last pass, we don't need to put it in a render target. So let's imagine we're going to add yet another one. I don't know, it will add a vignette effect. So I want to add a last one effect. It's going to be a vignette effect. I don't know if you know the word vignette. It's like when you add darkness on the edges, on the corners of the screen. It's kind of focus on the middle. It will look something like that. We don't put the last one in a render target because we are over with this ping pong render target thing, so hard to understand. You are just going to write it right on the screen because it's okay. It's the last one. We just put it on the screen and it will have all the previous effects. So this one, the UV that does like waves, stuff like that. We will have the little stars that we put above. I don't know, because your character just got hit by an enemy and now we can see stars or stuff like that. And because it's starting to fade out, is being knocked out, while the screen is starting to get like kind of dark from everywhere, and you just put it there. All right, that was the idea. Let me check if I didn't forget something. So yeah, the fact of having two render targets and read on one, write on one, is called the ping pong buffering. There are many ways, many words to explain this. Let me check. Yeah, that's it. So ping pong buffering. All right. And the final pass, we put it on the canvas, on the render. Because we don't need any more of those render targets, we just put it on the screen. In the end, do not worry. I know that was complex. Maybe you're thinking, oh no, this lesson is going to be the worst lesson ever. No, because we are going to use a class named Effect Composer that will do all of this. We have nothing to do. Why did I explain this? Well, it's because if you need to go further, to do more than what the Effect Composer provides you, you need to understand that, or you will be completely lost. You won't understand why there is two render targets, what's happening to the last one. Oh yeah, it's on the screen. Well, you need to understand those. It's also so that you understand that this is like heavy. It's bad for performances. When you do that, you do one render, two render, three render, four render. If you have like a huge screen with a pixel ratio of 5, you won't believe how much pixels you just rendered. It's billions of pixels. It's a bad idea. So now that you understand that, you will keep an eye on performances. And by the way, the effect, the passes we just explained, maybe we could have done them in one pass. It's better to do only one pass. Anyway, let's move forward. And we are going to use that class, which is Effect Composer. Much more easy. We just have to use it. You will see that it's really simple to use. So, yeah, yet again, this bug. Thank you, Photoshop. So, Effect Composer. Let's go. We are going to use Effect Composer. Obviously, Effect Composer is not available in the 3 variable because it's quite a huge code, and not everybody need to use Effect Composer in their project. To import it, well, it's inside the three examples, GSM, post-processing, effect composer, just like we used to add a loader, orbit control, stuff like that. So let's go, we'll put it right here. Import effect composer, oops, like that, from three examples, GSM, post-processing, and we will have a look to this folder. Slash effect composer.js. As always, when you import something with such a long path, just log it in case we did a mistake. So it's working great. And we can see, by the way, that it needs the renderer and the render target. Oh, by the way, there is a documentation about the effect composer right here. And you can use it. You better use the examples, by the way, which is why we have that many examples. But yeah, I don't know why the documentation, maybe by the time you're seeing this video, it's better. But documentation about effect composer is not really complete. It's hard to find the right thing. What I recommend is just to check the code of the examples. It's pretty simple. Anyway, we're going to do it together. So we have it. And what I wanted to show you is that it seems that the effect composer needs, a renderer and a render target. And actually, we don't need to provide this render target. One will be created automatically. So let's move forward. We are going to use the effect composer, but we are also going to use one pass, one very simple pass. It's going to be the render pass, and it's going to be kind of the first one. We put by the way, I can do like something like that. So this is, oops. This is effect composer. All right. We do all of this. And at the end, don't forget that put it on the screen like that. So we need a first render pass that will just take the scene, do a render, and put it inside the render target. Or if it's the only pass, it will put it right away inside the screen, because there is no need to use like render target if it's just one render. Because we need the renderer for the effect composer, we are going to put our code right after the renderer. Where is my renderer? Yeah, over there. So let's go. I'm going to put some comments just to see better. And I'm going to do const, I will call it effect composer. You can call it just composer or stuff like that. Post-processing, whatever you want. And we are going to pass to this effect composer, so this is the one we just imported, our renderer, like that. We can just save, make sure that everything is still working. Yeah, no error. Then what we need to do is kind of like the renderer, we need to provide a size and a pixel ratio. So effect composer, set pixel ratio. So it's exactly the same method, and we're going to use the same value, which is the pixel ratio of the screen, but limited to 2, because we don't need more. With a pixel ratio of 2, the image is perfect. And then we can set the size, and it's the same size. Usually you just use the same value, like size is width, size is 8, the same pixel ratio. Maybe if you want to go further, you can start tweaking stuff, but by default, just use the same as the renderer. We save, still no changes. All right, let's move forward. Then we need to use our render pass. So it's the first pass. We just do a render of the scene. So let's go. Const render pass equal new render pass. So it's the one we imported, I think. Let me check. Oh yeah, I forgot. Sorry. Yeah, I forgot this one. I just skip to the next part. So it's render pass. It was just a few slides ago. 3 examples GSM post-processing, and the name is render pass. All right, no surprise, it's exactly the same path, but different class. All right. Then we instantiate it. So get back to the right slide. Yeah, that's the one. And we need to provide two variables. It's the scene and the camera. Yes, it's exactly what we need when we do a render. It's because in the code right here, effect composer will do exactly the same, but put the texture in the render target if it's mandatory, if there is multiple passes, which is not the case right here. To add a pass to effect composer, it's really easy. You just have to do effect composer, add, and use your pass like that, and you just save. Still no error. Let's move forward. If you have an error, just pause the video. Right now, we are not using Effect Composer. We are still using the classic renderer. It's because in our tick, we're doing render scene camera. Here, we need to comment or remove this part and do Effect Composer render. All right. Before we were doing the render in the screen, the render of the scene in the screen. Right now we are using the Effect Composer, and we ask the Effect Composer to take care of the passes. And the only passes we added is a render pass, so it should be fine. You can just save. I know we didn't provide the scene and the camera, but the Effect Composer will just ask the first and only pass to do its job, and this pass knows that this is the scene and the camera, and will just do one render. And right now it's working. All right. Effect Composer took place of the classic renderer, which is great. We are going to be able to add more passes, and this is exactly what we are going to do. Here is some passes examples. So it's just the documentation of Effect Composer. There is way more passes. You can even download some from outside. You can create your own. We are going to create our own. Let's just have a look. Let's say the depth of field. I don't know. Yeah, why not? This one. Yeah, this one might be interesting. Yeah, this one, I really like this one. All right, let's just have a look. This is a depth of field, meaning that the one in the back are kind of blurry. This is a depth of field too. Sorry, it's not really visible. Yeah, looking great. Beautiful depth of field. This is the glitch pass. This is the God ray, like a divine light. Can do a lot with this one. This is some kind of masking. Yes, you can do masking, like use multiple things to mask things, but it can do a lot. This is the Unreal Bloom, looking great, inspired by the code for the Unreal Engine Bloom, I think. And this is another version of the Unreal Bloom. Well, those are just examples. We are going to use even more things. We are going to create our own. Anyway, let's start with a classic one, the dot screen pass. I like to start with this one because the difference is huge. First, you need to import the pass. So just like we imported the render pass, we are going to import a dot screen pass. You will see the result shortly. And to import it, yeah, put the right path. So post-processing dot screen pass. Post-processing dot screen pass. As always, just make sure that you didn't do any mistake. No error. Let's move forward. To add a pass, well, we already did it. We need to create a pass here. So const, I call it dot screen pass equal new dot screen pass. You can put parameters, but there are going to be default parameters, so I won't put anything here. And always add it to Effect Composer with the add method, add pass method. Maybe I say add earlier, it's add pass. And you just add the dot screen pass. And look at that, such a huge difference. I know it's kind of dark, but you can tweak the effect. We're not going to tweak it because we have a lot more to see. But as you can see, you can have like a huge difference and it's looking great. All right, let's move forward. By the way, you can deactivate a pass. You don't have to remove it completely. What you can do is simply dot screen pass enabled false. Enabled ed at the end, false. So your pass is already here, but it won't be used, so it's okay. No performance issues here. The pass won't even be used. All right, let's discover another one. So toggle the dot screen pass. I want you to get back to the render pass, and we're going to use a glitch pass. We are just discovering some passes. It's important, you will see why. So glitch path. This one is located in the same folder, but the name is glitch path. Let me check, no error, great. And then we can add it. So I will just, look at this, I will just duplicate everything. I will say enabled true. I know it's by default true, but this way I can just change them easily. So I duplicated the screen path for those 3 lines and I said enable true. This way I can just toggle it easily. I'm going to call it differently. So new glitch path. And instead of dot screen path, I will obviously call it glitch path, like that. Did I do a mistake? I don't think so. Yeah, look at that. Looking great. There is a problem. Maybe you saw it. Anyway, the pass seems to be working. It's kind of like when the screen got hacked in the movie. Just this kind of effect. By the way, we can also, like I said, for the dot screen pass, but we didn't do it for the dot screen pass. We can add, we can play with the properties. If the guys that did this pass allow it, you can play with the properties. So here we can play with the go wide properties. So go wide. Be careful if you are sensitive to lights and flashes and stuff like that. Maybe don't do it. I think it's okay, but just I want to warn you. I will use the go wide equal true. And you will say that it will just do that. It's just like wide all the time. And I will remove it because it's too much. False. All right, looking great. Next one is the RGB shift pass. Yeah, I really like this one. But this one is different. So first, let's do enabled false on our glitch pass. We will be able to add them back when we want. The next one is the RGB shift pass. It will kind of offset the different channels like RGB. You can have a really great result with this one. I use it a lot when I want something realistic to just like on the sides, it can look really great. Anyway, I want to show you this one because the way of using it is slightly different. Because the RGB shift pass is available only as a shader. All right, let's see how it works. If we want to import it, it will be RGB shift shader. All right, it's not a pass, it's just a shader. And you're going to find it in examples, GSM, shaders, RGB shift shader. I know there is a shader pass, I'm going to talk about this, but first import the RGB shift shader. And look at that. What do we get here? We get something with uniforms, vertex, and fragments. Oh, you know about this. You know perfectly about this. And you will be able to handle this easily. And the code is not that complex. So we have the fragment shader and we have nothing in the vertex shader. You can guess that at a point we are going to do that on our own. To use one of those shaders, so it's kind of a shader pass, you need to use a shader pass. Yeah, that's all. So you do shader pass. So it's a pass, you provide a shader to it. A shader is a uniforms, fragment, and vertex, and it will just use those shaders. So it's going to be in post-processing, GSM post-processing, and the name is shader pass, like that. And you can log it too, just to make sure that everything is working. Yeah, great. And we can remove the log. To use it, there is no surprise, it's just slightly different. Instead of just initializing the pass, we initialize the pass, instantiate, the pass, sorry, it's right here. So we do const RGB shift pass equal new shader pass, and we just pass the RGB shift shader that we imported right before, and we add it to Effect Composer. It's just one more step, small step to use a shader pass. So Composer, add pass, and we just add the RGB shift pass. Did I do a mistake? No, I don't think so. And it's looking like that. Pretty good. Yeah, I really like this one. I know it's way too dark. We're going to talk about this right now. What a timing. So yeah, as you can see, things are darker. What just happened? Well, since we are using Effect Composer, the colors are darker. I know it's not exactly true because when we just had this one, so let's disable all of them, like RGB shift pass, enable false, this one is enable false, and this one is enable false. All we have is our render pass. I'm not going to toggle it because we need this one. And it seems to be working. So when we are using a pass, I will say true, the color are wrong, like it's too dark, and we're not, now the color are fine. What's happening? Well, it's because when you just have one render pass, it's all you have in your code. The Effect Composer won't put it inside render target. Effect Composer will directly use this pass to draw on the screen, because remember that the last one will be draw on the screen. If there is only one, well, it's the last one, then it will be draw on the screen, and we will use like Nothing. We don't use render targets. We don't use the ping pong buffering stuff. We just draw on the screen just like we did before with one renderer, no effect composer, which is why we don't have a problem. But if we have any pass, we go into that loop of render target, stuff like that, and this is where the colors start to go wrong. The problem is pretty simple. It's because the output encoding doesn't work. Like renderer, output encoding, remember this one? If I remove it, look at that. See, it's darker. I still have only one render, and now it's darker. If I put it back, it's working fine. So it's like the output encoding when using render target is not working, and it's exactly what's happening. Our render target encoding is wrong. It's not using the sRGB encoding, and we need to fix that. And it's going to be pretty easily because Effect Composer already handled this. The idea is that we are going to provide our own render target. And if you look at the code, you don't have to do it, but you can just watch my screen. I will show you how I find out about this. You can go to the node modules and check the code. So I will go to the 3. It's going to be in the examples, GSM, post-processing, Effect Composer, no, post-processing I said, Effect Composer, and this is the one, Effect Composer.js. Effect Composer, as I told you, we create the render targets to do the ping pong thing. And this is the code where Effect Composer create the render targets. If you just pause, watch the code, you will see that those are the parameters of the render target. Oh, by the way, I didn't show you the render target in the documentation. My bad about this. So it's looked like this, and you can provide many parameters. All right, you can create those render targets, those buffer textures, by using a simple 3JS class WebGL render target. And these are the parameters that Effect Composer uses to create this one. So we have min filter, linear filter, mag filter, linear filter. I don't know much about those. Actually, maybe you know about those because we talk about mapping, stuff like that. The format, all right, RGBA format. I don't know. But if I look at the documentation, I can see that. Encoding, default, linear encoding. By default, if you don't provide an encoding here, you will get linear encoding, and we need sRGB encoding. What should I do? Maybe I should do something like that? Big mistake. No, do not change the content inside the node modules. You will mess with everything. If someone else gets your project, it will do npm install. It will get the version of Effect Composer without your modification. So don't do it. What we need to do is to provide as the second argument parameter of Effect Composer a render target. And if you provide a render target, Effect Composer will use your render target here and also duplicate it for this one, and it will fix the problem. So what we can take is just make sure that we are using the same parameter with the min filter, mag filter, and the format, and then add the encoding. I hope it was not too long. Anyway, let's start. So I'm going to create a render target. So where is it? Yeah, it's over there. Let's add some comments. We always need comments. So this one will be the composer. This one will be the passes, like that. And there we are going to create a render target. So const render target equal new 3 WebGL render target, like that. Maybe what would have been great is that the Effect Composer check the encoding of the renderer, because we provide the renderer. Yeah, that would be great, I think. Anyway, maybe I will do a pull request. For the size, because these are the two first parameters, you have to provide a width and a height. You can provide anything like 100, 100. It's not important because we are using the set size right after, and the set size will automatically resize the render target. I usually put like 800 by 600. Just maybe try to avoid like 0 or 1 billion or stuff like that. Should be fine, but anyway. Min filter, I'm going to use the same one here. So linear filter and format RGBA format. So I can just put it there. So these are the parameters you have to provide as the third argument, third parameters, which is an object. Be careful though, you cannot access those properties like that. In our case, we have to do 3.linear filter, like that. And then finally, we provide the encoding. And we are going to use the same encoding as before, sRGB encoding, like that. This render target, you send it at the second parameter of effect composer, like that. Finger crossed, did I do a mistake? Seems to be working, at least there is no error. Let's add back some effect. So first the dot screen pass, maybe. Well, it looks brighter. Remember what we had before? I can just show you. Look at this. It was dark. We cannot see really the small point, the small circle. Now it looks great. All right, let's try other ones. Maybe the glitch pass. Yeah, we don't really care about this one. The RGB pass. Look at this. Going to look great. Yeah, so much better. And see the effect. It's like the camera just got hit and some stuff inside got misplaced. And the camera is still working, but not great. I really like this one. Maybe not on the whole screen. I like to do it like just on the edges, on the corners. Well, anyway, let's move forward. So we created our own render target and send it to Effect Composer. And this render target has the right encoding. Looking great. We're going pretty fast. What about the resizing? Look at that. Oh, it's looking bad. Even worse, look at that. I will have a very small screen and I will resize it and look the quality. It's bad. So the problem here is that we are not resizing with the window. And that's all. We did this set size. It will resize our render target. So it's kind of the size of the texture. But when we resize the screen, the render target are not being resized because we let the code here. So what we are going to do is not that complicated. Oh, I forgot one small line of code. You can just take those two lines, so the set pixel ratio and the set size, and you will go to your resize callback function, which is over there, where we did the resize on the renderer, and we do exactly the same for the composer. So update composer, effect composer like that, and we put the same code. I know I forgot the pixel ratio, so put back the pixel ratio too. All right, it's just in case the user take its window and put it in another screen with a different pixel ratio. It will just also change the pixel ratio. So we save. I'm going to do the same thing. I will have a very small one, so it's looking okay. I will resize it, and it's still okay. All right, great. And that's all. That's how you handle the resize. Let's move forward. And we have another problem. We have a problem. It's hard to see. You can see it, but I think with the video compression, you might not see it on my screen. Anyway, if you have a screen with a pixel ratio of 1, just look and you will see that the anti-aliasing is gone. Like we can see the aliasing again. Look there. Look how bad it is. Maybe if you test with the glitch pass instead. So this one. So do enable true on the glitch path and enable false on the RGB shift path. Right here, see? When it's not glitching, obviously, we can see the anti-alias thingy right here. Look at that. It's looking bad. Where is my anti-aliasing? Why is it gone? If we have only one, look at this, we have only the render target, the render pass. Well, this one is looking good. We don't have like anti-alias problem. We cannot see those stairs-like effect. If we put only one new path, where the anti-alias is gone, you can guess it. Yet again, it's about the render target messing with stuff. So when we have only one render, well, the anti-alias is working, and when we are using a render target, the anti-alias is not working anymore. So how do we fix that? This is kind of complex. You will see why. The problem is that the WebGL render target does not support the default anti-alias. All right, we have multiple solutions. First solution, say goodbye to the anti-alias. Yeah, that's sad. Actually, I did it multiple times. I just couldn't understand why it's not working, and we didn't have the solution I'm going to show you. So I just said, sorry, boss, I cannot do anything about it. If you want effect, we cannot have we will have to deal with those stairs-like effect. Second solution, let's not use that one. We are going to find a solution. We can use a particular type of render target that handles anti-alias, but that won't work on all modern browsers. So we are going to use an anti-alias that will support a render target that will support anti-alias, but the problem is that it's not going to work on every modern browser. Third solution, we use a pass to do the anti-alias. So yeah, we are going to add a new pass, just like we added the glitch pass, the RGB pass. We are going to add a pass that will add an anti-alias. This is great. This sounds like a good solution, but actually it's bad for performances because adding pass is always bad. If you can just avoid adding passes because it's bad for performances. But that's a solution. We can do that. And finally, fourth solution is a combination of the two previous solutions where we test if the browser does support this render target, this new render target, and if the browser doesn't support the render target, well, we are going to use a pass to do the anti-aliasing. That was kind of long, but we are going to do it step by step. So first, what about this render target, this special render target? It's going to be pretty easy. Using WebGL multi-sample render target. This is the name of the render target, and you can just check the documentation. Look at this. We have WebGL render target. If I just write render target, we also have WebGL multi-sample render target. And this is the one that will support the anti-alias. And it's exactly the same anti-alias that we had before. It's the one that will do an anti-alias on the edges of the geometries, which is exactly what we want. So let's go. Let's use this one. The WebGL multi-sample render target is like the WebGL render target, but with support, and it's called the MSAA, so multi-sample anti-alias. Remember, it's MSAA, because we're going to mix with other types. So let's go, let's use it. It's really easy. You just have to replace the WebGL render target by WebGL multi-sample render target. Thank you, 3GS, for making this as easy. And as you can see, it's gone. We still have the effect, but it's gone. We don't have the problem anymore. We don't have the anti-alias, the aliasing issue. But this won't work on every browsers. And you can guess which one is messing with us. Here is the can I use of WebGL 2 because it's a WebGL 2 feature. WebGL has been updated I think it was a few years ago. And we, with those kind of support, so WebGL multi-sample render target, stuff like that. And unfortunately, not all browsers support WebGL 2. The ones that is really missing with us, so we have old version of Edge, which are okay because they are not really used. The problem is iOS and Safari. The usual. Yeah. I have a good news. By the time you're watching this video, maybe it's working on Safari, on the latest version of Safari at least, because it's currently being supported in the technology preview. It's like the beta of Safari, where they just test new features and they test for quite a few months until they are sure that it's working. And if everything is working fine, they put it in the live version. So by the time you watch this video, check this. Don't check my screen right now. Check the links I put in the links panel with can I use WebGL 2 and watch if it's working on the latest version of Safari. Anyway, we need a solution because we need this code to work on Safari 2 for now. All right, cool. So let's get back to the previous version. We can remind this. We are going to mix them, you will see. So get back to the WebGL render target where it's working with Safari. And what we are going to do is add a pass. Just like we added those dot screen, glitch, RGB shift pass, we are going to add a pass. And we have the choice. We have many choices actually. Here is just some of them. I'm not an expert in anti-aliasing. I've been reading a lot of articles because I just find it really interesting, but I'm not an expert in that. So I just try to give you my knowledge about this. We have the very famous one. It's the FXAA. It's performant, but the result is just okay and it's kind of blurry. It doesn't look really good. We've been using the FXAA on games for years, and now FXAA is being replaced by more advanced anti-aliasing. The next one is the SMAA. Do not confuse with MSAA. So it's not multi-sample anti-alias. It's a sub-pixel something complex, I don't know what, anti-alias. It's better than the FXAA because it will use an algorithm to detect where we need to do changes, and if there is no need for applying an anti-alias, it won't apply it on those particular areas, but it's less performant. It's good, you can use it on your project, but be careful, you might have like a small frame rate drop by using this one. And there is also the TAA. It's a temporal anti-aliasing. I really don't understand this one. It's performant, like really performant, but it won't fix every anti-aliasing issues. There are many others. All right, it's just my knowledge about this. Maybe I said something wrong. If so, I'm sorry. But anyway, we are going to use the SMAA. Right? It's not MSAA, it's SMAA. Oh, by the way, I maybe forgot. Yeah, SSAA. We talk about the SSAA. It's super sampling anti-aliasing, or FXAA. It's for full screen anti-aliasing. It's the same. FXAA and SSAA. It's the same thing. It's when you do a render twice as big and put it back to the initial scale. And this way you will have like 4 pixel render instead of 1 that will be mixed, that will be merged into one. And it's just look great, but it's really bad for performances because you render 4 times more pixels. So try not to use this one. I know I did use this one on my portfolio, but it's because the performances were just great. So I say, okay, let's go for the SSAA. Maybe it was a bad idea. Who knows? I know it's a bad idea. Anyway, let's move forward. We are going to use the SMAA. So it was a pretty long stuff. So let's go. I'm going to import it. So it's SMAA path. So it's available in the 3GS dependency. It's going to be inside the GSM post-processing and the same name. So SMAA path. Like that. Yeah. As always, maybe make sure you wrote it the right way. Yeah, it's working fine. So as always, I log it. So import this one, then add it to the passes like that at the end. All right, because there is an order, by the way, and maybe I forgot to tell you, but there is an order. So you want to add the SMAA at the end, like the final result. Const SMAA path equal new SMAA path, and you add it with effect composer. Composer add path, just like that. And check that out. Yeah, it's looking great. See? We cannot see the stairs anymore. And it's actually even better on specific situations, but it's bad for performances. All right? If you can avoid it, avoid it. And it's exactly what we are going to do. We know how to use the WebGL multi-sample render target. We know how to use the SMAA path. We are going to do a mix depending on different factors. Follow me on this. It's just like the right condition, the right thing at the right moment. The idea is that we didn't talk much about this, but if the pixel ratio is above 1, we don't need that because there is no aliasing issue. If you have like a lot of pixels, you won't see the stair-like effect. Even worse, because you have a pixel ratio like to 2, you have already more pixels to render. It's kind of having the SSAA. It's bad for performances. So let's not add even more anti-aliasing or SMAA. You're going to have frame rate issues on those computers. So yeah, if the pixel ratio is above 1, we use the WebGL render target and no anti-alias path. All right, and that's all. If the pixel ratio is above 1, we just set the render target and nothing else. No anti-alias. If the pixel ratio is 1 and the browser supports WebGL 2, we are going to use this new render target named WebGL multi-sample render target. And if the pixel ratio is 1 again, but the browser does not support WebGL 2, we use the render target because we have no choice, but we are going to enable the SMAA path, the one we just added here. So it's the worst case scenario. It's Safari with a pixel ratio of 1. All right. Let's do it. To get the pixel ratio, we can use get pixel ratio. Yes, we could do like window get device pixel ratio, but we want the pixel ratio used in the renderer or in the effect composer. We're going to do it on the renderer. And to know if the browser supports WebGL 2, we can use the capabilities on the renderer. So you can just check this one. So right here, if I do renderer capabilities like that, look the result, we get some information about what is supported by the browser and the computer. We can have like maximal attributes, maximal cube max size. I don't know about those. What I want is this, is WebGL 2. If this is false, well, WebGL2 is not supported. We cannot use the render target, multi-sample render target. So let's move forward. Let's go. Hang on, we can remove this and it's going to be over there. So it's about the render target here. We are going to use a render target if it depends on the pixel ratio. Hang on. So first I'm going to create a variable just to store this constructor. So I will do let render target class equal new. And I'm going to store WebGL render target or WebGL multi-sample render target depending on the pixel ratio and what is supported by the browser. Follow me on this. If renderer get pixel ratio, so first we get the pixel ratio equal 1 and renderer capabilities is WebGL2. So if the pixel ratio is 1 and we support WebGL2 features, we can do render target class equal 3 WebGL multi-sample render target. So right now, this variable, which was new at the beginning, now contains this. So the WebGL multi-sample render target. Else, I will just put the default, which is this one. So if the pixel ratio is 1 and we do support WebGL multi-sample render target, well, let's use it. Otherwise, let's use the default one. And because we just stored like the class, like the constructor in this variable, instead of doing new 3 WebGL render target, I will do new render target. So this one or this one. Now we add some logs, like using WebGL render target, and we're going to test on Safari. And I will do the same here. You don't need to do those tests. You can just watch my screen when I will test. All right, let's refresh. All right, looking great. So right now, I'm using WebGL multi-sample render target. Let's test on Safari. Safari, like that, like that. It's working, great. But as you can see, using WebGL render target, not the good one. All right, so we are using the right one depending on the support of WebGL2. I know that you can see the aliasing here. It's because I already added the SMA pass. All right, so then what we need to do is to activate this pass only if it's needed. The idea is that if the pixel ratio is not 1, well, we don't need to add it. So I'm going to do renderer gets pixel ratio. So it's the same. If the pixel, I will add this one only if the pixel ratio is 1 and the WebGL2 is not supported. So it's almost the same condition. So if the pixel ratio is 1 and WebGL2 is not supported, I will add this pass only like that. And I can use log, and I can add a log like using SMAA. So right now, we are using WebGL multi-sample render target. All right, looking great. I have a pixel ratio of 2 screen here. You cannot see it, I know. I just refresh. Trust me, it's written using WebGL render target on the other screen because the pixel ratio is above 1. I don't need any anti-alias because I already have enough pixels on my screen. So it looks great without any anti-aliasing. And then if I use Safari, I will open it again. Should not have closed it anyway. So we just put that here, open the console, and you will see using WebGL render target, because we don't have access to WebGL multi-sample render target, but also using SMAA, so that we don't have the stairs. And that's all. I know it was kind of long and complex, but you can just use this code, and your pictures will look great on every browser, every screen. So yeah. Now that we fixed that, let's add one more pass. I just wanted to show you this one. We are going to go pretty fast on this one. It's the Unreal Bloom pass because it just looks great. It's too much, but anyway, I really like this one. You can add it. So Unreal Bloom pass. You import it from post-processing Unreal Bloom pass like that. As always, you can just test. I think I got it right. And you add it. Be careful, you have to add it before the SMAA, and you will do const Unreal Bloom pass equal new Unreal Bloom pass, and you add it with add pass. Effect composer, add pass like this. Look at that. Whoa, what's happening here? Well, it's working. It's just kind of burning our eyes, so we need to change that. We have access to 3 main parameters. I think there is more parameters, but these are the one I use. The strength. So how strong is the glow? As you can see, this one is too high right now. The radius, it's how far the glow can go. And the threshold is kind of the limit, like under this limit there is no glow, above this limit there is glow. So let's go. I'm going to just change those properties. You can do Unreal Bloom Path strength equals 0.3, like that. And I'm going to multiply it. We have the radius. I will put 1. The threshold, obviously you can tweak them, change those, put anything you want, but we are going to add them to that GUI to have more fun with it. So right now it's more subtle. Trust me, there is 1. It's just that we cannot see much of it. We are going to tweak it anyway, and to tweak it, well, it's always the same. GUI add. The GUI instance is already in the code. Unreal Bloom pass, and we are going to start with the enable, and we just provide enable like that, and we see that it will add a checkbox. See the difference? Yeah, there is one, and this one is subtle, because you can just use the Unreal Bloom pass to add a subtle effect on the screen, which is just like the user will just enjoy it without knowing that it's there. Or you can start like pushing the values like hell and see them, but it depends on what you are trying to achieve. So we add the strength like that, min 0, max 2, step 0.01, and we add sorry, wrong, so the radius from 0 to 2, why not, and the threshold like that. I think I got it right, yeah, from 0 to 1, because the limit is 1, and as you can see, we can just play with it, play with the radius. Yeah, it's working great. All right, cool. I just wanted to show you this one. Don't use it too much, please. All right, cool. So that's it for the default passes. There is way more passes, just try them. We're going to create our own pass now. And we're going to create, I think, 3 passes, from the very simple to much harder. Creating a pass is like creating a shader. Just like you saw, I think it was for the RGB shift shader, you just have to provide a vertex shader, which will be always the same, a fragment shader, and uniforms, and some uniforms. So let's go. We're going to create a tint pass. By that, I mean like be able to slightly change the colors. So this glitch pass is starting to annoy me, so we'll put it to false. Sorry if you had to see it like on the side of your field of view. We're going to add our own pass. So let's get rid of this one. I put false on the glitch pass. So enable false. So let's go. We have to provide uniforms. It's the same format as the uniform we are used to. We have to provide the vertex fragment, always the same, and a vertex shader, and then a fragment shader that we do the post-processing, all right? It's this part there that we add some post-processing on the plane. Let's go. So where are we going to put it? I think we're going to put it, yeah, right here. Yeah, why not? We can put it there. Yeah, too bad I put this, so maybe, yeah, just make some room. Tint shader, like that. Tint pass, I'm going to call it tint pass. So we create tint shader. It's just an object with the following properties. So we have uniforms, all right. We have the vertex shader, all right. I'm going to use backquotes as always. You can put in different files if you want, but I want everything in the same file. It's easier for you. It's not going to be like huge code, so anyway, we can just put it in backquotes and try not to make mistakes. And the fragment shader. And then we can add it by doing const tint pass. I know this won't work because we didn't provide anything here. Equal new shader pass, just like we did for the RGB shift pass. So shader pass, and we provide this tint pass with a uniform vertex and fragment, like that. And we add it to effect composer with effect composer, add pass, and we use the tint pass, like that. We get an error, obviously, because we didn't put anything here. So the first part is simple. Actually, you can write it, I think. It's just put the vertices where they are supposed to be. We are going to do void main, and it's like a shader, not a row shader. So we already have access to everything we need, like the matrices and stuff like that. Remember, GL position equal, it's the projection matrix, the model view matrix. So it's the model matrix and the view matrix as one matrix. Why not? It's faster to write. I'm okay with that. And we provide a vec4 using the position attribute, and we add just one value, 1.0, like that. And this one should be fine. We are just placing this plane in front of the camera where it's supposed to be. All right, cool. And for the fragment shader, where you can start easy with just putting a color. We want to see if this is working. Maybe we did a mistake. So first, let's see if we did a mistake. Maybe I did a mistake, actually. I wonder. Main, we do GL frag color like that, and we provide a vec4 because RGBA. So vec4, 1.0, 0.0, 0.0, 1.0. So it's red. Finger crossed. Yeah, it's working. All right. If you don't have a red screen, pause the video, check if you did a mistake here, watch for the semicolon, watch how many values you put in there. Make sure you use vec4, you wrote this right. Just make sure of everything. So right now what we are doing, it's just putting the plane where it's supposed to be. It will be in front of the camera. And we just put a red color because we just put that. Obviously, what we want is to get the texture of the previous under target. All right, we just added one more pass. We need to get the texture from the previous pass. So how can we do that? Let me check. Is it now? Yeah, it is. The pass will be automatically added by Effect Composer as the T diffuse uniform. It will look like that. You have to provide a T diffuse uniform. You don't have a choice. You cannot call it like U diffuse, stuff like that. T for texture. And Effect Composer will check your shader. You say, oh, there is a T diffuse. All right, I will put the previous pass texture on this one. Actually, it's the render target containing the previous render. And you will be able to use it. All right, so you put it like this. You set it to null. And Effect Composer will put the right thing inside. And then you can just use it. You can do like, never mind. Uniform sampler 2D. Remember this one? It's for textures, like a uniform, which is a texture. The type is sampler, sampler, not sample, sampler 2D, T diffuse. And to pick the right pixel on the T diffuse, we are going to use texture 2D. So we can do texture 2D, maybe I will call it like vec4, I don't know, color equal texture 2D. The first parameter will be that uniform texture. And the second parameter, remember this one? Well, it's the UV coordinates. It's where on that texture should we pick the color. And we have a problem. We don't have the UV right here. So we are going to send the UV from the vertex to the fragment, and we are going to use a varying to do that. And you know that. If you forgot, it's okay, but now I think you know that if you did the previous lesson. So varying VUV, I like to call it VUV, and then I update it anywhere inside my main function. I do VUV equal UV. Because the UV is the attribute, we cannot see it because it's like a shader material. The code will be prepended, so it just exists right before, but we cannot see it. And we update our VUV like that, and we can add it there. And then we can use it, because we got it from the vertex shader, we can use it inside the texture 2D like that. So VUV like that. Finger crossed, no error. Great. We still have a red screen because we didn't change the color. Let me check if I use the same thing. Yeah, it's color. I can put back the color in the GL frag color. Instead of putting a red value, I would just use what I took from that texture, and I get back this. We didn't change anything, but right now, with those simple lines of code that you probably can understand, I know it's hard. If you have still troubles understanding that, it's normal, it's hard. But still, I think you can understand most of this concept. What we can do now, because we have access to the previous texture, is play with that texture, and we can do like R plus equal 0.1, like that. And now it's look reddish. And if you put, I don't know, some blue too, we get some kind of purplish, and it's looking great. And we can just tweak the colors like that. You don't have to change all the textures and all the materials and stuff like that in order to get the right color. You can just change the tint on on this pass. We're going to go a little further. We're going to send a uniform, so it's going to be uTint, in order to control the R, G, and B values with that GUI. So we're going to put a value, and we set the value to null. By default, always set the value to null here. We're going to change those after initializing, after using the shader. So you put a uTint to null, and we can add to the RGB, instead of changing those like that, we do RGB plus equal the uTint, and I forgot to import it, so I will do vec3, because it will be a vector 3, so that we can change the R, G, and B, and do uTint like that. All right, so we create a uniform, which has nothing inside right now. We retrieve the uniform here, and we add the value of that, the three values, so R, G, B, X, Y, Z, to the color right here. We save, we usually get an error, yes, because we didn't send anything. Right now it's null. We need to change it after doing that. So we are going to do tint pass material. We can access the material like that, which is great, much more simple. Uniforms uTint value, and we set the vector 3, new3 vector 3 like that, without any values, so that it's going to be 0, 0, 0. And we can test, and it's working. And if I do something like 0.200, you will see that it's going to be red, because I increased the red value. I will let it to 0, but what we are going to do now is add those X, Y, and Z of the uTint to that GUI. So let's go. I will do GUI add tint pass material uniforms uTint. I could have duplicated this one, value. The property I want to change first is the red, so it's the X for vector 3. I will put a min value to -1, a max value to 1, more would be kind of strange, a step to 0.01, and I will put the name red. Damn, that was long. Yeah. Let me check. And yes, it's working. You can now control it. Let's change the other one. So it's the Y and the Z. I will put red, green, and blue, like that. And I can change the blue, like add a lot more blue, a little red, and change the green, and increase the grid. Well, you can control the tint. It's way too sensitive. Maybe we should like lower it to 0.02, 0.2, minus 0.2. Anyway, it's looking great. We're going to do another pass. So this was kind of the most simplest one. I know I was quite fast on this part. Just pause the video, do it again. It's because we already did those. All right, we are using what we've learned in the shader part, but right now for doing post-processing. The next one is about displacement pass. We are going to do some displacement, meaning that we are not just going to play with the pixels color, we are also going to like deform the things. Instead of taking the pixel right here, we are going to take it here. And you will see like things start moving, deforming, stuff like that. And we can do whatever we want if we are capable of putting it into a formula. So what we're going to do first is simply make the things waves. You know, I like to do waves. We are going to make the render do waves like that. It looks like if we are drunk or something like that. So first we're going to duplicate everything. So you take your tint pass. See, I'm starting right here to here. I copy it, not the GUI, stuff like that, because we are going to remove the uTint. And I will put it, so let me just add so I'm going to do Unreal Bloom Pass, Red Shift Pass, RGB Shift Pass, Glitch Pass. I just like to keep things organized and well commented. Dot Screen Pass, Render Pass. This one was the Tint Pass. Don't forget that there is also a SMAA pass, and before the SMAA path, But after the tint pass, you passed what you what you copy. So it's this part to this, like that. And I'm going to name it not tint pass, but displacement pass. Here I'm going to do displacement. I don't need any U tint. For displacement shader, I remove the U tint. I need the VUV, so I can keep it. I need the T diffuse. I can remove the U tint like that. I try not to go too fast, so follow me. I need the VUV to get the previous texture. I need the color. I can keep this one. I remove the U tint like that, this one. I change the tint pass by displacement pass. I change the shader by displacement shader like that. And I can remove this uniform here like that. I save. I get the exact same result. I still have my tint working, but now I added a new one right here. All right, it's the displacement shader, and we are going to displace the things. We can do a small test without going too fast. What you can do is play with the VUV. What we are going to do is create a new one. You cannot change the varying, so we're going to create a new one. I'm going to call it vec2 new UV. Yeah, I wasn't inspired on this one. Equal VUV, like that. So you create a new one in order to be able to change it, and you put it here, right? You use that new one. If I save, I get the same result because I'm not doing anything with it. It's the same thing. But right now I can change the UV, meaning I will not take the pixels where I'm supposed to take the pixels. I will just offset them. And you can do like VUV Y plus equal 0.1, just a small offset. And as you can see, things moved down. So the 0 is at the bottom, and when you are increasing the Y, it's going down. If you put more, you will see a very strange result. Yeah, why not? Remind me of this movie, it's not Inception, it's Interstellar, you know, with the library, almost at the end of the movie, where the books are kind of stretched like that when he starts traveling in time. Well, I won't spoil you if you didn't saw it. Anyway, it's looking great, but this is not what we want to do. What we are going to do is make the things waves, sinus. You should have known this one. So we are going to do things slightly differently. I will do vec2. So it's exactly the same thing. I will do vec2. I will use the VUVX and the VUVY. I did the same thing. I just put the X and the Y by myself inside the vec2. So if I save, I get the same result, but the Y, I'm going to change it and do plus sinus, and the sinus is going to vary depending on the VUVX. And I will just multiply it so we get a nice result. If I just do that, you will see that, oh, damn, the amplitude is too strong because a sinus goes from -1 to +1. So it's way too much. What I can do is just multiply it by 0.1. So it goes from -0.1 to +0.1. And we get something like that. I think it's looking great. Depends on what you want to achieve, but it's just an example for the lesson purpose, and it's looking really great. So let's move forward and animate this. Obviously, we need to animate. You know, I like to animate things. To animate it, it's just like we are used to do it. We are going to add a U time uniform so that we have an animation, a time-based animation. We set it to null. We could have put 0, but we're going to set it to null and change it right after. We retrieve that uniform here, so it's a float, U time, like that. And we add the time to the sinus here, so that the sinus, the value we put inside the sinus will change with time. We put it like this. If you save, you don't get an error because a null will be converted to a 0. So, but it's not animated. You can guess what we are going to do. We are going to animate it inside. Oh yeah, so first we put it to 0 just in case. So displacement pass material uniforms U time dot value equals 0. And take this one because we are going to change it inside the tick function. All right, we put it to 0 to make sure that we have 0. But now we're going to the this one, and we are going to the tick function. And we're going to update it. And we're going to do update, well, passes. We only have one thing to update, but anyway, U time value equal, and we get the elapsed time. So how much second was spent since we reloaded the page. Elapsed time, and see that? Yeah, perfect to get sick. Like sick, I think we say. Yeah, it's looking great. Really depends on what you want to do. If the player drank too much alcohol, well, he gets drunk and start to see things like that, and you mess with the controls. If you move forward, well, you move backward or stuff like that. Anyway, let's go even further, and we are going to do another displacement, so we can capitalize on this one. We are going to remove this wave effect and do a better displacement map. And we are going to use that thing here. So let me show you. I created a texture just for you. Took me hours, should not, but it took me hours to get this texture. And as you can see, it looks like a normal map, and we are going to use that to create a displacement and have some kind of futuristic interface with like if there was like glasses with bump on the glasses, and you see that it will displays the image. It looks great. So let's go. So what are we going to change exactly? First, we need to load this one. We can remove this. Yeah, you know what? Let's remove what we did with the utime just to have a simple code. So remove the utime here, remove the utime there, remove this one. Let me check if we need to remove this one. Yeah, remove this one. So we just do like, instead of putting the sinus here, we will do VUV like that. You can remove this one because it doesn't exist anymore. All right, we remove it here. We just did new UV equal VUV. We removed it from here, and in the tick function, you also need to remove it like that. All right, it was just a test to animate thing, and we get the default one. Yet again, we can play with the new UV. I'm not going to explain everything because I really messed with the code until it looked good. So I cannot explain it because I don't know what I did exactly. I just tried stuff until it was fine. You will see that it will look great. I will try to explain a few parts of it, but not everything. So first we need to send that texture, and this is what I wanted to show you. So how to send a texture. Just like we have the T-diffuse being sent, well, we can send our own texture. I'm going to call it uNormal map, all right, because this is kind of a normal map. So let's go, uNormal map. We set the value to null. Do not put the value right here because it will work if you put your texture right here. But though this is like a template, a shader is like a template. You can use it multiple times with different textures, all right, which is why try not to put the values in here. You instantiate it and then you change the values. So we did it, so uNormal map, and what we're going to do here is change the uniform, so it's displacement path. I think we are going to change it right away. Yeah, that's it. We're going to do material, uniform, so we want to change the uniform, so uniforms with an S, uNormal map, value, equal, and this time we're going to load it directly inside of it, all right? We can do texture loader because we already have a texture loader in the code. Right here. I don't know why we have a cube. Yeah, because we have another environment map. So texture loader, load, and we set the path. So it's, follow me on this, textures, because it's inside the static function. So textures slash, well, it's just interface normal map.png, like that. So sorry, it was a lot. Maybe I can just put this part here. It doesn't look great, but anyway, this way you can see the code more clearly. You save. Looking the same, but right now we did send a texture to our shader, and we're going to use that texture to move the vertices a little, move the UV a little. So let's go. And this is the part, I'm sorry, I won't be able to explain you, but it will look something like, so it's a sampler 2D. I will use the uNormal map. You can take my code if you want to use it anyway, just take the code, you will see that it's working. So right now I retrieve this texture. So it's a uNormal map. I can show it to you, by the way. What I'm going to do is I'm going to take it there. So vec for, I'm going to call it normal color equal, and I do the same as I did to get the texture from the T diffuse. I will do texture 2D, the texture, and I'm going to use the VUV like that. All right, just test it, and I can show you by putting the normal color inside the GFR color. So we are not using this part. We are just trying to show the normal color. And it looks like this, so it's working. So we get access to the texture. Make sure that you have the texture by putting the normal color here. It's not what we want to do, so let's get back to the color, and we're going to use those data. And what I will do, right now it's really the moment where I just tweak things until it works fine. I will just take the RGB because I don't need the alpha, so I will do X, Y, Z, or you can put RGB, it's the same. And right now, RGB, those values, because it's just pixels, it goes from 0 to 1 for R, 0 to 1 for G, and 0 to 1 for B. Me, I want the displacement to be able to go in both directions, so I will do multiply by 2.0 and minus 1.0. This way it can go from -1 to +1, all right? I can save it. Well, actually, it's not a vector 4, it's a vector 3. So change it because we don't need the alpha. So I just took the X, Y, Z and multiply and did a subtract on it. And then I'm going to change the new UV. It's going to be the VUV plus I'm going to use the X and the Y. This is the part where I just tried stuff until it worked. So I'm going to use the X and the Y because I don't know how to use the last one. So I just did that. And look at that. All right, it's working. And that's all. Like I was like, okay, this is fine. I like it this way. Obviously, it's way too strong. So what you can do is simply multiply it by, I don't know, 0.1. Yes, why not? And you see that there is some kind of displacement and it's looking pretty good. Like a beehive effect, like the interface of an alien with a helmet, with screens, stuff like that. It can be whatever you want. And what I didn't like is that I cannot really see. It's just a displacement, but when you have like lights bouncing, it should look like different on the side of the beehive shapes. What I did, and this is even worse, I just really tried. I created a vector that is supposed, I just want to add like lights on some edges, but always the same size. So I created a vec3, which is a light direction. It's just a direction. I will create a vec3, and I say that the direction is from the right and top, so it should bounce something like that. I just try stuff again. So I put 0.1, minus 1.0, sorry, 1.0, 0.0, and it's just like a direction, all right? And a direction, it's supposed to be a length of 1. So I normalized it, so normalize like that. Remember the normalize? It will give you any vector, it will put its size to 1. It's the same direction, but it will put the size to 1. Because it's a light direction, I use normalize on it. It's not that important. Yeah, actually it is. So keep the normalize on it. And then I will calculate the lightness by doing float lightness equal, follow me on this. So it's a clamp. So we can do like a dot normal color. So I take the normal color, which is the direction of the pixel. So it's kind of the direction. All right. I take this one and I use it on a dot product. I will try to understand, to explain to you what is that. And you can try it by doing vec4. Look at that. Lightness, 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 1.0. Let's see what we get. See those? We get that. A dot product, see my fingers? When you have two vectors, like one doing this and one doing this, if they are facing, you will get 1. So I have the direction of the surface, which is what I got from these textures, and I have the direction of my light, and if they are facing each other, I get 1. If they are like that, I get less. Like here, I got 0, I get 0, and like this, I get like minus something, and like this, I get -1. It's kind of telling you if it's pointing, one vector is pointing to each other. And I take this value, like I do a dot product. If those vectors are pointing at each other, well, I will get white because it's 1, because I used it to color the frag color. I will just instead mess with the color of the texture. I will do color plus equal, which is kind of wrong because I'm also changing the alpha. So color.rgb, I did a mistake in the code. Don't watch this part. It's going to be plus equal lightness, but not too much. because oh no, actually more. So I multiply it by 2 so we can really see it. And then I show the color on the GFrag color. And it looks like this. Look at that. The problem is that because the value can be negative, we get some black here, all right? Because if they are not facing each other like that, we get -1. So we need to also limit it. I will use simply a clamp to be sure that it doesn't go below 0. I will do clamp on the lightness and use 0.0 as the bottom limit and 1.0 as the top limit. Could have do a max too. And we get something like that. I know this part was fast, but I'm bad at this. I just tried stuff, and this is what you're supposed to do. Try until you get a good result. Maybe check on the internet, trying to find some snippets and understand them. Anyway, if you did understand, this is great. It's over. How can we go further? Well, first you can try other passes. There are like dozens of passes. Just try them, just in order to know that they exist, and maybe at a point you will need them. You can try to create new passes. Maybe you have ideas, so try them. Add displacement tweak to that GUI. Yes, because we just put values like 2.0, stuff like that. Well, add them to that GUI in order to be able to control the displacement. And finally, yeah, separate the shaders into different files if you can, because right now it's a lot of code. Maybe we should have separated. And that's all. Oh yeah, one final word. Keep in mind that each pass can add, we have to be rendered on each frame, meaning that each pass, it's bad for performances. If you add like 10 passes, we have a frame rate drop. Try to merge them into one pass if you can, and try to avoid adding passes. That's all. And yeah, we are over for this lesson. I'll see you in the next lesson.